Everyone, thank you for joining the commercial prescriptive training for the 2022 Denver Energy Code. I'm Courtney Anderson with Denver's Office of Climate Action, Sustainability, and Resiliency. We're really excited about this training, which is our second training in the commercial series. And these trainings were developed with our partners in community planning and development. I know people are still joining, but since we have a lot to cover today, we're going to jump right in now. And to get us started, I'll hand the training off to Linda Morrison in CPD.
Sounds good. Welcome to today's presentation, which is about the commercial prescriptive path. The presentation is 2 hours in length. I'm Linda Morrison. I lead the Energy Review Team for Community Planning and Development. I'm delighted to be with you today to make sure that you have a great understanding of what's new in the prescriptive path. After our prepared material, we'll have a question and answer session. If you could please advance the slide, it shows where you'll find that Zoom Q&A button. During the session, the moderator will say the questions out loud so our community planning and development panel can respond. If we're unable to provide an answer during our time together, we'll answer it via email. This presentation is recorded and will be posted to the website. Please join us for other training sessions in the series. If you could please advance the slide through either the live or the recorded version. Please help get the word out by sharing what you've learned and links with your colleagues and other interested people. For continuing education credit, for people who our continuing education credit is available for people who attend the full session. If you happen to call in by phone instead of using your laptop and want to get credit, please email Tom Gleason, tom.gleason@denvergov.org, so he gets your full information and can process that continuing education credit. Let's move to the timeline, which recaps Denver's plans and goals for commercial and multifamily buildings. The 2022 Denver Energy Code became effective on May 1st of this year, and it's a step in a series of steps that takes us to our ultimate goal of zero greenhouse gas emissions. Energy efficiency is very important, but it alone does not achieve the goal. It takes a combination of efficiency, electrification, and a greener grid. This means we all have a part to play in making these changes. We also have time to accomplish them. I wanted to point out in the third row of this timeline that in 2025 and 2027, there are additional electrification requirements for space heating and water heating. The code includes input from a wide variety of community members and stakeholders, so a big thank you to all who contributed. You'll find our 2022 Denver Energy Code at denvergov.org/building code. Let's move to the next slide. A package of proposed changes to the code is posted there and is anticipated to get City Council approval in early June. The updates are primarily housekeeping, and the presentations have a preview of the updates. Please do check back for the latest. Denver-specific ComCheck and ResCheck are anticipated to be available in fall of 2023. We have tips on compliance in the interim in this session. And then another spot for resources is the Net Zero Energy Hub. If we could move to that slide. It's at denvergov.org/energy code. This will have a recording of the presentation, as well as resources for specific provisions, compliance options, and additional trainings. More resources are being added in May and June, so be sure to check back. And last, for me, tips on referring to we also have new building electrification resources available at that website too. Okay, one more slide for me, and that is tips for referencing our energy code. And that is that you'll hear us use a single reference to the 2022 Denver Energy Code. This is because the 2022 Denver Building and Fire Code adopts the base codes as a reference. So it's a good practice to check Denver's code first to see if there are any deletions or modifications to a section, then reference the base code. Now let's jump into today's presentation. Tom Gleason with the Office of Climate Action, Sustainability, and Resiliency is our moderator. And John Arndt with NORESCO is our presenter.
Thank you, Linda. Our training today covers the prescriptive requirements of the Denver Energy Code. We will review the material needed to submit a project for permit and review the prescriptive code requirements for all of the building components with an emphasis on the new changes for the 2022 Denver Energy Code. We will also cover the requirements for all newly constructed buildings, which include new requirements for electric vehicle supply equipment infrastructure, solar access, and commissioning. Now, while this training focuses on new building requirements, we will also note changes to existing building alterations. There are also electrification requirements covered in detail in a previous presentation. Also, note that the performance compliance approach is another compliance path for new building projects, and that will be covered in a separate training. Now, first, let's go over the Denver Energy Code Submittal Overview. We will go over the submittal requirements and the prescriptive checklist tool overview. And later in the presentation, we will focus on the C406 energy credit requirements that are needed for prescriptive requirements, which vary both by building occupancy and project. Let's take a moment to review how Denver defines commercial buildings. The residential provisions of the 2022 Denver Energy Code apply to residential buildings that meet the definition from the 2022 Denver Energy Code. Residential buildings are detached 1- and 2-family dwellings and multiple single-family dwellings or townhouses, and group R3 and R4 buildings 3 stories or less in height above grade plane. The commercial provisions of the code, the Denver Energy Code, apply to new buildings with conditioned space that are not defined as residential buildings, and any such buildings undergoing an addition, remodel, alteration, repair, change of occupancy that would result in an increase in demand for either fossil fuel or electrical energy or change of use. Now, just a quick housekeeping, we're going to be referring a lot to the Denver Energy Code. If I mention Denver Energy Code, please assume that it's the 2022 update unless I otherwise indicate it as an earlier version. New to the 2022 Denver Energy Code is the definition of an all-electric property. This is used in several places to facilitate easier compliance for all-electric properties. An all-electric property is one that contains no permanently installed equipment or appliances that utilize combustion, plumbing for fuel gas or oil, fuel oil, or fuel gas utility connection installed within the buildings or site, except for emergency power systems and standby power systems. Emergency power systems and standby power systems are defined in the code, where the interruption of the primary power could result in the loss of human life, serious injuries, or could create hazards or hamper rescue or firefighting operations. So, would a project that includes an outdoor gas fireplace, as an example, meet the definition of an all-electric property? No, if the gas fireplace is permanently installed, it does not meet the definition. Let's review the process that's required for any commercial project. All projects will need to choose a compliance pathway and then comply with the requirements. Teams will need to review the requirements of the Denver Green Buildings Ordinance, the Denver Green Code, and commissioning and air leakage testing requirements that apply to all projects. All projects will need to use the checklist to document the requirements of their selected pathway, which may vary. The checklist is also where teams will report their 2030 EUI energy use intensity target for the Energized Denver Ordinance. Now let's compare the two major compliance options, prescriptive and performance. With the prescriptive approach, it's easy for a project team to know exactly which energy efficiency measures are required, because each and all of the prescriptive requirements of the Denver Energy Code must be met. Now, this path requires no building energy model and is a straightforward compliance process. Requirements are documented on the prescriptive checklist. Compliance documentation should include CompCheck verification. We'll discuss the interactions with CompCheck and its updates a bit later in the presentation. In contrast, the performance compliance path offers more flexibility and aligns with a whole building design process, as it allows for interaction between building systems and components. Efficiency measures in excess of the minimum requirements may be traded off with other lower performing systems, as long as the modeled energy use meets the performance requirements specified. In either case, prescriptive or performance, the requirements in section C407 of the Denver Energy Code must be met. We'll review those later, but those include things such as commissioning and performance verification for building envelope. There's a separate training that covers the performance compliance approach in detail. To identify the selected compliance path for the Denver inspection team in our current process, the reviewer will enter in this information. The inspector has easy access to the permit, but not necessarily the drawings. The reviewer will enter the compliance path in the scope of work box on the permit as one of the 4 options listed, as well as whether the property is all electric. So the last 3 options there, the energy cost, site energy, and performance target, are all performance compliance options. In the future, e-permits will be updated with a field for the design team to enter. Energize Denver is Denver's building performance standard for existing buildings. Buildings that are 25,000 square feet and larger have 2030 energy use intensity targets under Energize Denver. These projects must report their 2030 target in the permit submittal to raise awareness. While these EUIs are not part of the compliance metrics, it is recommended that they are considered as part of the design process for success with Energize Denver in the future. So you notice in the table on the right, there's some target EUI levels for different building types. And of course, a building such as a restaurant that has high process loads will have a higher energy use intensity than an office or a multifamily building. So this is a future-looking requirement. The Denver Energy Code prescriptive checklist tool is available on Denver's website as a handy summary of prescriptive requirements. The completed checklist references drawings and specifications and supplemental material where appropriate to aid in the building code review. The user must document general condition requirements common to all projects and define the prescriptive envelope, lighting, HVAC, and service water heating requirements. So you notice in the 2 shaded fields for this sample requirement, this is just an excerpt, there's a place to reference the drawing from the construction documents set that shows that that requirement has been met. This will facilitate review by the building code official and streamline the process. The Denver Energy Code prescriptive checklist also contains a planning tool for C406 additional efficiency credits. The 2021 IECC expanded the list of credits, and Denver added more options and requirements by building type. The credits selected must be the same across all disciplines: electrical, mechanical, and building envelope. We'll look at the C406 requirements in much more detail later in this presentation. For now, I'd like to highlight that the tool is available to support teams. For best results, coordinate electrical, mechanical, and envelope design at an early stage to meet the total in the Denver credit requirements. Excuse me. To use the Denver Energy Code prescriptive path, additional efficiency credits are now required for new construction, as well as non-previously occupied tenant spaces for prescriptive compliance or change of occupancy under section C505.1. Although the entire calculator is not captured here, it is important to note that for each efficiency credit, you can select credits with a simple yes or no, Y or N selection from the appropriate building type from the drop-down box in the tool for use in planning. Denver has clearly noted what documentation they expect to be provided and has a quick reference to the thresholds for each measure, although the section number here is provided for users to review the entire code requirement. So this shows, again, another excerpt with the heating and cooling efficiency improvement requirements. We'll go over this in a bit more detail later. I would like to point out, I may point this out a second time for emphasis, is that the column shaded in green indicates which of the requirements are already covered as part of CompCheck under IECC 2021. We'll review the process of updating CompCheck and how that affects the compliance process a little later in the presentation. Denver streamlined the checklist policy to make this easier for teams. Each tab in the checklist should be included on the drawing sheets within the project's construction documents, separated by discipline. Since the drawings will have the appropriate stamp and signatures, no other signatures are required. CompCheck will be updated to reflect the new prescriptive requirements and the new C406 energy credits of the 2022 Denver Energy Code. This is anticipated to be completed in the fall of 2023, this year. In the interim, projects will have to demonstrate energy compliance with all applicable prescriptive requirements of the code. Some of this can be documented through CompCheck using 2021 IECC for sections that are not amended by Denver. Where sections have been amended, supplemental documentation and calculations are required. Include full compliance documentation and CompCheck inspection checklists in construction documents. We will look at a few examples of documenting compliance in this presentation. The performance approach is another option for compliance during this interim period. Another item that is required to be documented by all commercial buildings, commercial projects, is compliance with the Denver Green Buildings Ordinance. Requirements will vary by project type and size. Teams can select from a broad menu of strategies that will help Denver to achieve more sustainable development. You can find more information on the GBO webpage. New to the rules and regulations for the Green Building Ordinance in 2023 is that energy conservation options for new construction, which require an extra 12% or 5% savings beyond code, also require the project to be an all-electric property. These options are typically done in conjunction with energy modeling for a performance path. There are some exceptions for the Green Building Ordinance for certain roof reflectance for certain types of buildings. The Denver Building Code, section admin 101.4, requires compliance with the Denver Green Code, regardless of which energy compliance pathway you choose. All new commercial construction projects and major renovations will have limited mandatory use of the Denver Green Code. The definition for a major renovation or commercial is an alteration that is a level 3 alteration per the Denver existing building code, and additions that are either 100,000 square feet or greater than 50% of the existing project gross floor area. Projects will choose a certain number of credits from each category as shown in this table. They have options with site sustainability, water use efficiency, energy, and indoor environmental quality as well. This is designed so that teams can choose options that are cost-effective and fit well with their other project goals. The link here will take you to a web page where you can learn more information. Now we're going to get into the the building envelope for the new prescriptive requirements for the Denver Code. There have been a few changes to the building envelope, which we'll review in detail. Some of these are also expressed in terms of as energy credits, which we'll review later in the presentation. The prescriptive envelope requirements have increased the required insulation for some assemblies. For example, there's a slight increase in continuous insulation requirements for steel frame walls and wood frame construction. Also, there is a new maximum U factor requirement or minimum insulation equivalently that applies to all compliance paths. This limits the trade-offs that can be used with a performance approach. And it also limits the trade-offs that can be done with ComCheck with a component performance alternative. A lower fenestration U factor is required for a new category designated as all other fenestration. This required U factor of 0.30 is slightly more stringent than other classifications of windows, and it would apply to windows such as architectural windows. While interlocks are required for operable windows to set back heating and cooling set points when windows are open, projects that use evaporative cooling may still have the cooling system enabled when windows are open. That's just a minor clarification applicable to Denver in its dry climate. Air barrier testing is now required for commercial and multifamily buildings. Projects that do not meet the leakage requirement but are less than 150% of the required level may take diagnostic measures to identify and seal leaks without retesting. Minimum insulation requirements are now in place for certain above-grade opaque envelope components. This is a mandatory requirement that must be met for all new construction projects, regardless of the compliance path chosen. So you notice at the table here, the new maximum U factor, and now this would apply both to prescriptive and performance levels, that it is a little bit less stringent than the existing prescriptive requirement, but it's intended to limit the trade-offs to ensure that all projects have a minimum level of envelope performance, since often those envelopes aren't updated or altered during their building's expected life. For example, the maximum U factor for wood framed construction is 0.064. This is equivalent to a 2x4 frames assembly with R3.8 continuous insulation, or a 2x6 framed assembly with only R20 cavity insulation. It's a little bit less stringent than the prescriptive requirement, but it still requires a minimum level of insulation to meet this requirement. The minimum insulation requirements are regulated by component U factor. They're not as stringent. And for an inspector and contractor, the performance backstop exists so that the load reduction and energy performance is baked into the enclosure. It is in the U factor. Use the assembly drawings with R values to verify. Be sure to protect the minimum insulation requirements in the code. Now, there has also been an update to the prescriptive insulation requirements for a couple minor places. There's a prescription insulation requirement update for certain opaque assemblies, such as roofs, attic and other, metal building walls, metal framed walls, and wood framed walls. These levels were increased on the update from the 2019 Denver Energy Code to the 2022 Denver Energy Code, and largely reflect the changes in IECC. So for the prescriptive insulation requirements, we have an option to express them in terms of R value or U factor, but for the mandatory U factors that I showed on the previous slide, those would be determined in terms of envelope assembly U factor for the entire assembly. Now there's a special adjustment derating factor that's handled for exterior cladding that use Z-girts. Z-girts are galvanized steel framing members that can provide multiple functions. They provide support for continuous exterior insulation and also attachment for exterior cladding. The code adjusts the R value of the continuous insulation by a derating factor of 0.7 for horizontal Z-girts and 0.6 for vertical girts, aligns with the studs. The assembly U factor can be determined by combining the U factor of the steel framed assembly with the effective R value of the rigid insulation with this structural framing. So the simple example shows an example of a steel frame wall with cavity insulation and 2 inches of rigid insulation using vertical girts. There's an equation used, a simple equation for combining the effective R value for the resistance of the exterior insulation with the Z-girts to the main cavity insulation. So the continuous insulation of R12 would be derated by a derating factor here of 0.6. So effectively, it would have an R value of R value of R7.2. And then that would be used to determine the U factor for the assembly. Now for fenestration, there's an update to add a new U factor requirement, as I briefly mentioned before, for all other fenestration. This covers architectural windows and other assemblies not covered under the other categories. For this type of window, a maximum allowed U factor is 0.30, which is slightly more stringent than the other assemblies. Now note that since this is a Denver-specific update, the ComCheck will need to be updated to reflect the new prescriptive requirements and new C406 energy credits of the Denver Energy Code. If a new project is submitted for permit before this update is completed, projects will have to demonstrate energy compliance with all applicable prescriptive requirements. Some changes will have to meet prescriptive levels. The component performance alternative method, which is a method where you can use within the prescriptive compliance approach to trade off envelope performance of different components, will not be available within the ComCheck tool until it is updated in the fall of this year. Similarly, other changes impacting the lighting allowance, such as the inclusion of residential lighting, will also not be available until that update is complete. And as I mentioned before, besides documenting these changes prescriptively, the performance approach is yet another option for compliance during this interim period. Excuse me. ComCheck will be updated to reflect the new prescriptive requirements. And as I mentioned before, projects will have to demonstrate energy compliance with all applicable prescriptive requirements. So essentially, wherever there is a Denver-specific change that's been made, such as the maximum U factor requirements, the lighting changes, that these will have to be updated within the Denver Energy Code in ComCheck in the fall of 2023. And until that period has been met, you'll have to use either the prescriptive compliance approach or interim requirements. Now let's look at an air barrier and thermal envelope as an example of documentation. We're going to go through some of the air sealing and leakage test requirements a bit later in the presentation. Section 1C103.2.1 requires that the location of the air barrier, sealing details, and building thermal envelope are represented on the drawings. This multifamily project provided a thorough depiction of the thermal envelope, an air barrier and plan, and its section, as well as clearly showing the heated drop ceiling at the garage marked with a red hash. The C402.5.1.5 building envelope performance verification instructions are also shown on the drawings. The Energy Code section covering air barriers and air leakage testing, section C402.5, has been updated. Continuous air barriers are required throughout the building thermal envelope. A review of continuous air barrier in construction documents is required. An inspection of the components is required, along with air leakage testing and possible corrective action tests if the leakage tests do not meet the performance requirements of the code. That's a summary of the envelope changes to the code. We will review a little bit more about envelope changes with the energy credit section of this presentation. For the mechanical here covers, for this purpose, covers the heating and cooling systems as well as ventilation systems for the project. A summary of the Denver Energy Code prescriptive energy changes. One of the new changes is fault detection diagnostics are now required for buildings of 25,000 square feet or larger. Now, for some of the smaller buildings that use packaged equipment, these control options can also be often be embedded in the system controllers that are available as an option for these systems. There are limits on fossil fuel and space heating, and these are effective January 1st, 2024. They require electrically sourced space heating for most new systems. There are some exceptions for heat pump, supplemental heating, and reheat. Economizers. For airside economizers common on many rooftop systems, the requirement has been extended for smaller systems. So now any systems with a capacity of 33,000 BTUs or or greater require airside economizers. This effectively sets a requirement for systems with a nominal cooling capacity of 3 tons or greater. There are energy recovery requirements for systems with outside air ventilation rate exceeding minimum thresholds. When required, there are also limits on the pressure drop across the energy recovery device, as well as supply fan efficiency requirements for that energy recovery system fan. There's a section that was previously specified here as 403.7.1 and has now been relocated as C403.7.8 for outside air controls that apply to energy recovery ventilation devices, dedicated outside air systems or DOAS, and makeup air systems that report when the systems provide excess outside air. For systems with an outside air flow rate above 4,000 CFM, direct airflow measurement is required. So this is essentially a requirement as a checkpoint to ensure that excess outside air isn't delivered to the space, which would increase the cooling and heating loads when it is not needed. So for the first requirement, HVAC fault detection and diagnostics, it's a new mandatory requirement for buildings with an HVAC system serving a conditioned floor area of 25,000 square feet or larger. There are systems that are exempt, including those that serve warehouse buildings with heating only systems and those serving R1 or R2 occupancies. An example of a system where FDD is required would be an air handling unit serving areas of an office building totaling no more than 25,000 square feet. So these systems commonly can both detect and report faults and raise those levels of faults to an alert system and notification system where applicable. For smaller, medium-sized buildings where there may not be as dedicated maintenance staff on hand for each building, it's especially useful to have these systems in place that can detect faults before they become either chronic energy increasing faults or faults that actually impact the operation of the system and detract from the expected life of the system. Now, there are also partial electrification requirements for space heating. These requirements will become effective January 1st of next year. Fossil fuel warm air furnaces and electric resistant space heating equipment will not be permitted for space heating. The focus is to trend towards electricity-based space heating systems over fossil fuel where applicable. There are several exceptions for this requirement. One of the exceptions is for use in a standby power system or emergency backup power system. Makeup air systems where energy recovery ventilation is prohibited is another exception. And there are also exceptions for electric resistance in buildings that comply with the performance approach, or an electric resistance that's used for supplementary heating for heat pump water heaters and heat pumps is allowed. There's also a budget available of up to 5 watts per square foot of electric resistant space heating per square foot of conditioned floor area that does not include supplementary heat. Replacement for gas-fired furnace equipment that complies with the existing building section C503.3.3 is another exception for the electrification requirements. The code limits the use of heating systems that use fossil fuel equipment. Some equipment, such as central boilers for space heating, are allowed. As of January 1st, natural gas heating is no longer allowed in rooftop units and gas furnaces. Electric resistance heating is restricted in systems such as smaller PTAC zonal systems. Some electric resistance heating is allowed as reheat for systems that use VAV reheat systems for air distribution. Dedicated outside air systems are an excellent choice for conditioning ventilation air, especially when coupled with zonal systems for heating and cooling that can cycle on and off with the load. It limits the use of outside air to where it's needed, and those DOAS systems can often use energy recovery to limit the heating requirements further. Some fossil fuel systems may be able to comply with the performance pathway if they meet the specified requirements. Refer to the commercial performance training for details. There are an increasing number of system options for heating in commercial buildings. For smaller commercial and retail buildings, heat pumps that serve a single zone are a common option, and systems are commonly available with capacities up to 25 nominal tons. Split system heat pumps can also be used for smaller spaces, especially those such as control rooms or spaces that do not require ventilation. For larger buildings, there's a movement towards providing additional design options for heating, both space heating and water heating. Water source heat pumps and air-to-water heat pumps can be used to serve multiple zones. Variable refrigerant flow, or VRF, systems are also an option for medium-sized commercial buildings. Electric heating systems are often paired with dedicated outside air systems to provide ventilation. And as I mentioned, they can cycle the systems on and off with the load and have the DOAS system being the only system running continuously to serve the ventilation need. This will serve as to reducing the fan energy for improved energy performance. So these are just some of the options available. There's certainly a number of options available beyond these listed. Due to the Denver Energy Code air leakage requirements covered on the previous slide, the Denver Mechanical Code states that ventilation must be provided by mechanical means to all dwelling units regardless of building height. This means that dwelling units are not allowed to rely on natural ventilation via optical windows. One of the reasons why is that buildings have become increasingly airtight through construction practices, resulting in reduced air leakage requirements, and the use of natural ventilation, especially on taller buildings, may impact the building pressurization. The Denver Mechanical Code does not allow for exhaust-only ventilation as a mechanical ventilation strategy in any building type. Where mechanical ventilation is provided or required, ventilation must be required by a combination of supply and return or supply and exhaust. So a balanced system is required. As is common in other jurisdictions that use, say, a continuously running bathroom exhaust fan to provide ventilation for dwelling units, this option is not required. This option is not allowed in the Denver Mechanical Code and the Denver Building Code. The Denver Energy Code has new requirements for data centers. The code builds upon ASHRAE 90.4 requirements and has increased energy performance for the data systems serving the data center, the heating, the cooling systems that condition the data center. The mechanical load component, or MLC, which is the ratio of energy consumed by the HVAC systems to the facility energy consumption, is set at 0.20 for design power at or below 300 kilowatts, and is set to an even lower value of 0.12 for larger data centers with an IT equipment load over 300 kilowatts. That would apply to most medium to large size data centers. The code prohibits non-adiabatic humidification, such as the use of steam in data centers. Direct injection of water vapor is allowed. Recent studies have indicated that data centers can often tolerate a wider range of humidity levels. Also, pertaining to the water side, the code requires the use of recycled water where available. If there's no recycled water available and there's only potable water available, then that would be an exception to this requirement. Some large data centers providers use water treatment as a way to treat gray water so that it can be used in evaporative cooling towers. Without going into detail, evaporative cooling towers, while efficient on an energy perspective, consume a great deal of water. So there's a trade-off and there's an increasing desire to limit the use of potable water for use with data centers. The code also requires a new requirement that's just a reporting requirement to report water use effectiveness, to report the water consumption for these data centers. As is common procedure, hot aisle, cold aisle containment is required for most data centers to be able to effectively reject the heat and not have the heated air in close proximity to the actual servers. Economizers are a prescriptive requirement carried over from the 2019 Denver Energy Code. The requirements for chilled water system economizers have not changed. However, for individual fan systems, especially for packaged equipment, the cooling capacity which triggers the need, or the requirement rather, for an economizer in buildings other than Group R has been reduced to 33,000 BTUs per hour. Given that economizers are a prescriptive requirement, a project may pursue a performance compliance pathway for a design without economizers. One other note that in blue on this slide is that there is a pending clarification that VRF systems, the variable refrigerant flow systems that use dedicated outside air systems for ventilation, do not require economizers. You can look for that update in June of 2023. The Denver Energy Code has energy recovery requirements for a broad range of commercial buildings. The requirements are more stringent for systems that operate continuously or more than 8,000 hours per year. For systems that operate on a daytime or a daytime schedule, such as an office or retail building, the requirement varies with the outside air requirement. So the greater the outside air intake amount, the more likely the system is to require energy recovery. Energy recovery systems must meet minimum efficacy requirements. Many systems have a bypass or bypass damper to reduce the system pressure drop when free conditions allow. So that would allow you to bypass the energy recovery device for a lower pressure drop when you can just simply have free cooling and do not need the energy recovery during mild outside air conditions. This example describes an HVAC system for a building with a 12-hour day, 6-a-day week HVAC schedule. The system requires a minimum outside airflow of 7,200 CFM, and it has a design airflow of 12,000 CFM, and which results in a minimum outside air fraction of 60%. Since this outside air rate exceeds the threshold for energy recovery, an energy recovery system is required. Note that since energy recovery is required, the fan system can take a pressure drop allowance when calculating fan power and comparing against the requirements in section C403.8.1 of the Denver Energy Code. So this is just an example of a system that would require energy recovery for the prescriptive tables that we had just reviewed. Next, I'm going to be covering service water heating. I do notice there's a little bit of Q&A. Just a note to the audience that is participating is that we will have opportunities for question and answers at the end of the session. We have a bit more material to get through, but we're looking to be on schedule for that. Service water heating requirements have also been updated and fall under the prescriptive requirements. And as I mentioned before, as with the other types of requirements, there are options for energy credits to comply with that section of the Denver Energy Code. A major change to the Denver Energy Code restricts the use of fossil fuel-based water heaters and electric resistance water heaters. The code limits electric storage water heaters to those with a rated tank volume no greater than 20 gallons. This promotes the use of heat pump water heaters, particularly in new construction. The code does provide allowance for electric heat in recirculation loops for larger systems and allows point-of-use heaters when installed within 10 feet of their associated fixtures. Gas water heating is allowed to systems that require water temperature of 141 Fahrenheit or greater, such as commercial dishwashers and laundry that may require higher temperatures. Demand response controls are now required for water heating with storage tanks between 40 and 120 gallons that reset the hot water set point in response to a demand response signal. Water heater location requirements provide electric-ready capability for future installation of heat pump water heaters. And we'll go over those a little bit later. Water heating end uses may also be met with electricity-based heating systems. Heat pump water heaters may be used to serve a single load or a central load. Beginning January 1st of 2024, the code prohibits the use of gas storage water heaters and gas instantaneous water heaters, with a few exceptions. Exceptions are allowed for resistance heating elements within the heat pump water heater equipment, electric resistance elements used in a recirculation loop for temperature maintenance for a central system. Exceptions are also given for electric storage water heaters allowed for tanks smaller than 20 gallons. And indirect hot water storage tanks that have no heating elements, so basically serve as storage, are also allowed by the code. Heat pump water heaters are a good substitute for gas storage and electric storage water heaters. For larger apartment buildings, central heat pump water heaters are available that have an electric resistance heater for backup. There are a few important design considerations for heat pump water heaters. Their operating conditions are typically limited to 40 degrees Fahrenheit and higher. So they're, they're best located in semi-conditioned spaces such as garages, closets, or basements. They require either sufficient clearance or for ventilation or venting. If located in a conditioned space, they will tend to draw some heat from the surroundings, leading to an increase in heating requirements. They should also be located in a space with some acoustic separation from the occupied space, given their general acoustic performance. For water heating equipment locations, they must meet requirements for electric readiness, regardless of the equipment used, to facilitate future installations. The code specifies space or bedding requirements for water heating equipment to allow for future installation. So this is located under section C404.12 of the code. There's a requirement for a space of 3 foot by 3 foot by 7 foot or larger, or 760 cubic feet, or to have direct venting. Manufacturers also provide recommendations for heat pump water heaters as far as location, space requirements, and venting. Next, we're going to be covering the the power systems and lighting system changes to the requirements. These systems, excuse me, these requirements cover the interior lighting as well as electrical infrastructure. Now note that there is a separate training on electrification, which will cover some of these electrification requirements in further detail. First, let's go through just a brief summary of the key changes to the power and lighting sections of the Denver Energy Code. There are new prescriptive changes to commercial lighting requirements. The Denver Energy Code requires all luminaires in dwelling units to be high efficacy lamps with a minimum efficacy of 65 lumens per watt. Now, this is slightly more stringent than the 2021 IECC, which allows up to 10% to be lower efficacy. The building area method in C405.3.2.1, which is contained also in the IECC, provides a simple way for projects to comply with lighting requirements using a simple watts per square foot allowance for the entire building. The Denver Energy Code removes the exceptions for residential occupancies when using this approach, the building area method, for lighting compliance. For example, multifamily lighting power allowances of 0.45 watts per square foot and the dormitory lighting power allowance of 0.53 watts per square foot would apply to all spaces, including dwelling units. If a building has difficulty complying using this approach, it can comply using the space-by-space approach. The code also includes a new control requirement for dimming by at least 10% in response to a demand response signal. Now, just to show us an example for multifamily lighting compliance, if you had a multifamily building with 24 units, the project is 30,000 square feet, and the total interior lighting for the building is 16 kilowatts, or 0.53 watts per square foot. Since the lighting from all spaces, including the residential dwelling units, is included, the project would exceed the allowance of 0.45 watts per square foot. So this doesn't mean that the project would not comply at all. It just means that the project would have to use the space-by-space method to demonstrate compliance with the Denver Energy Code. The space-by-space method requires manual calculations to compute the watts per square foot for each room with interim comm check. Now, as I mentioned a couple times before, the workaround for comm check has been put in place until the actual comm check is updated in the fall of this year. If a new project is submitted for permit before this update is completed, projects will have to demonstrate energy compliance with all applicable prescriptive requirements. Some changes, such as envelope changes, as well as this lighting change, would not be available under comm check. So this change, as it's Denver specific, to incorporate residential dwelling units in the lighting power calculation for the complete building method, that method would not be available until comm check is updated in the fall. So as I mentioned before, there's a couple options. One would be to use the space-by-space approach, and the other, of course, could be, as always, using a performance approach for compliance. The 2022 Denver Energy Code contains new requirements for parking infrastructure to facilitate the addition of future electric vehicle chargers. The code has requirements for solar access to ensure that there is adequate roof area available for PV installation. The electric infrastructure requirements are covered in a separate training in this series, the electrification training. We will review the requirements in summary here. Under section C405.12 of the code, there's a new requirement for electrical energy monitoring as a mandatory requirement for all projects. This requirement requires for electrical consumption data of various energy use load categories to be measured, monitored, recorded, and reported separately for new buildings 25,000 square foot and larger. So the energy use load categories identified are HVAC, interior lighting, exterior lighting, plug loads, process loads, and other miscellaneous loads. Could be a pool or could be an elevator for the miscellaneous loads. Now, in the reporting, the HVAC system here for the purposes of reporting would include both the heating, ventilation, and water heating in the HVAC system load category. There are exceptions for tenant spaces 2,500 square foot or less from this requirement. Electric-ready infrastructure requirements are also been added to the Energy Code for 2022. These requirements allow newly constructed buildings that use permitted fossil fuel appliances to more easily transition to electric systems in the future. The requirements include the use of a junction box and raceway that can serve for future electrical equipment, a space for a 3-pole circuit breaker, and labeling also indicating that it is reserved for future equipment. So this is, again, a forward-looking requirement for electric ready so that buildings that don't have all electric systems can be easily retrofitted into the future. The code requires that a zone designated for availability of solar photovoltaic panels, or PV, be indicated on the construction drawings. Now, I want to distinguish a solar-ready zone from the solar itself. While there is no mandate for rooftop PV, an area that is 60% of the free roof area, which would exclude setbacks and designated spaces for rooftop HVAC equipment, must be available for solar panels. Existing shading from neighboring structures that would cause the roof to be shaded for the majority of the daylight hours triggers an exception for this requirement. And so we're looking for the roof orientation 110 degrees to 270 degrees from true north, the low slope collectors, and buildings 6 or more stories above grade would be exempted from the solar ready requirement due to the relatively low solar roof area available relative to the building floor area. Electric vehicle requirements has also been changed for the since the 2019 Denver Energy Code. The language and definitions were updated to align with national level code language of the IECC. Electric vehicle infrastructure installed station quantities were increased in the new codes, but overall, the requirements were decreased through the reduction of EV capable spaces. So in some cases, there were increases in the installed space requirements, but corresponding reductions in the EV capable spaces, such, for example, that the for R2 occupancies, the multifamily, there was a decrease in the electric vehicle infrastructure that previously covered 100% of spaces to now covers just 60% of spaces, with 40% of those as capable and 15% as installed spaces. Note that there are universal parking space requirements in the Denver Commercial Building Code, Section 1107, that must be met in conjunction with the electric vehicle requirements in the 2022 Denver Energy Code. Next, we're going to talk about additional efficiency package options known as energy credits. These are contained under the section C406 of the code. They require buildings to achieve credits from table C406.1. There are different credit requirements for all electric properties, as we'll review, and for mixed fuel buildings based on building type. The intent of the credits is to provide for additional energy efficiency while at the same time maintaining flexibility for project teams. There are new credits that incentivize electrification but still provide a path for mixed fuel buildings. An all-electric property still needs to do more than just the baseline all-electric space heating or all-electric water heating. Note that there are new credits available specific to Denver for renewable energy, cold climate heat pumps, demand responsive thermostats, and reductions in fan power relative to the allowance. Prescriptive compliance requires that a project comply with the entirety of all applicable provisions in sections C402 through C406 and with C408, the commissioning. Additionally, projects will need to comply with the additional energy credits required by section C406. The amount of credits that a project must comply with is dependent on a building type and whether it is an all-electric building or not. So for all-electric buildings, there are simply 10 credits or credit points that must be met regardless of building type. For a mixed fuel building, the right-hand column, the credits vary by building type, but are ranging from 30 to 40 credits. Tenant spaces, additionally, must attain a total of 10 credits from the lighting and HVAC sections of C406. Note that this is higher than the 2021 IECC requirement of 5 credits. Projects meeting the requirements of C407 and using a performance approach option are exempt from the credit requirements. So these are only applicable to the prescriptive approach. Envelope credits help reduce loads and equipment size and should be considered first. Envelope credits are available when using efficiency building opaque assemblies and fenestration assemblies. Credits available for projects that show a reduced UA factor or overall envelope factor when using the component performance alternative calculation approach. Note that this was something limited by the ComCheck implementation prior to the fall rollout. When using this approach, the Denver Energy Code now places limits on the maximum U factor assemblies as we reviewed earlier. Air leakage testing is required for all buildings. For buildings that have a confirmed high level of air tightness through testing and reporting of reduced air leakage rates, credits are available for reduced infiltration. Efficient lighting systems can provide a significant portion of the required credits, particularly for the retail or mercantile occupancy group. An interior lighting power reduction of at least 10% is required to claim a credit. Additional credit beyond C406.3.2 is allowed for lighting power reductions greater than 15% from the base allowance. This is referred to as a proportional credit because the credit can exceed the 15% for even additional energy credit levels. We'll review that as an example a little bit later in the training. Enhanced digital lighting control is a credit available to all occupancy groups except residential multifamily buildings. This credit requires advanced control capabilities, including continuous dimming and load shedding, as well as individually addressable luminaires. A common system that can achieve this are luminaire level lighting controls, or LLLC. These systems have great savings potential by enabling control of individual or a small group of luminaires to either dim or shut off in response to occupancy, daylight levels, or other factors. Energy credits are also offered for all electric, water, and space heating. These credits cannot be claimed for an all-electric property. So remember the table we had just reviewed that had the reduced number of credit points for all electric facilities. That was exclusive of these credits. For HVAC, there are a number of energy credits available. Some of these I'll point out right away. The cooling efficiency and heating efficiency are also deemed as proportional credits, meaning that you can get even higher levels of credits for demonstrated reductions beyond the 10% threshold for cooling and heating. There are also credits available for dedicated outside air systems and cold climate heat pumps. Credits are also available for reduced fan power. We'll review the cold climate heat pump as a Denver specific credit in this presentation. High performance projects that have equipment efficiency levels more than 10% better than code requirements can have even higher credit totals. Now note that some credits, when required by code, would not be eligible for energy credits. So for fault detection and diagnostics, this credit is only available when not required prescriptively. So essentially for the buildings with a floor area of less than 25,000 square feet. Service water heating. High efficiency service water heating equipment can qualify for a large number of credits, especially for Group R and I projects. Energy credits are available for service water heating systems that derive at least 70% of heating energy from a renewable source. That renewable source could either be a solar hot water system or recovered heat from a heat recovery chiller, such as condenser heat recovery, or even heat recovery from a process load or waste heat stream. Credit is also available for efficient fossil fuel service water heating, such as condensing boilers that have an average efficiency of at least 95%. Note that starting January 1st of next year, fossil fuel water heaters are not allowed to provide service hot water except for boilers. So after this date, the credit will only be available when the alternative is a boiler. Heat pump water heaters are an effective means of heating water and are rated with an energy factor. A new credit is available for projects with heat pump water heaters with a weighted average efficiency of 3.0. To avoid drawing heat away from occupied space, these systems should not be located in the conditioned building envelope unless the cooling effect is desired. A parking area, garage, or mechanical closet with adequate space for venting are acceptable locations. Projects can claim specific energy credits for efficient kitchen equipment as well. For renewable energy credits, projects can claim credits in excess of the minimum renewable requirement in proportion to the capacity of the photovoltaic or PV system installed. However, there's a maximum energy credit or cap at twice the level of the basic credit. So if the credit is 0.25 watts per square foot of floor area, and you have more than 0.5 watts per square foot of photovoltaics, you only get twice the basic credit as a limit. And so this is designed to limit the types of trade-offs between renewable energy and energy efficiency. Okay, and now we're coming to an example project. And we're going to introduce a sample project to show how the CO46 credits will work, and also how to use the prescriptive checklist tool and planning tool within the prescriptive checklist. Our example project is an 18-story mixed-use multifamily project. It has a parking garage and a featured tenant space on the ground floor. There's an outdoor pool served by a gas boiler. Some of the design strategies used for this project are high efficiency HVAC equipment, they decided to use water source heat pumps that's supplemented with a gas boiler for backup. They're using a dedicated outside air system with energy recovery for ventilation, reduced infiltration throughout the building, and a central heat pump domestic hot water system for water heating. The building also has efficient lighting, and the lighting was designed so that the overall lighting for the entire building has a lighting level of 0.3 watts per square foot. That compares with the code allowance of 0.5 watts per square foot. So what we're going to do, we're going to simply show how this project would size up using the energy credit tool in the prescriptive planning. Now we're going to switch out of the presentation. Hopefully everyone can see an example of the prescriptive checklist tool. What we're going to do first, before we get into the details here, I just want to take a half minute to show you what's covered in the tool. We did talk about this briefly during the earlier part of the presentation. I want to put this to memory to connect what was talked about as far as what's required for documentation. So the first tab has the project instructions for the Denver Energy Code Commercial Compliance Checklist. There is a general compliance tab here at the bottom, and then a tab for each of the major end uses: building envelope, HVAC and kitchen, and service water heating. The general compliance tab is where projects would document requirements for Energize Denver, as well as things like commissioning and performance verification that would apply to all projects. And as I mentioned before, there would be a place here to enter in the associated drawing for the construction documents that is a demonstration that the requirements have been met. Now let's go to the C406.1 credits tab and show how this project sizes up as far as energy credits. So the energy efficient credits, now just note that although there are options to meet this requirement, the credit point total or credit total for building credits is a requirement within the prescriptive checklist. So we want to make sure we can meet that. First, we'll look at the all-electric option for the project. We know that this is not an all-electric building because it uses a gas backup boiler for the water source heat pump. If this were selected yes, the amount of building energy credits here would be much lower. We will enter our floor area by building type or occupancy group, which is predominantly multifamily building with some office. Once we've done that, the tool will calculate the building credit requirement for this project, which is 40 credits. Next, we want to look at each of these efficiency measures that we show in our example to understand how we can enter these in the tool. So I'm going to scroll down and look at, here we see all of the requirements listed. Before I get to the individual credits, I want to point out this special cell highlighted in green for column D indicates whether or not the credit is included already in ComCheck IECC 2021 version. So there are some credits, such as the additional efficiency improvement credit, the excuse me, cold climate heat pump credit, that are Denver specific that would not be included. So those would have to be not be eligible until the tool is updated in the fall of this year. Let's look at the cooling efficiency. Let's assume, we didn't specify it on the slide, but let's assume that the cooling efficiency exceeds the minimum requirement by greater than 10% for both cooling and heating. Then we can simply, for the building occupancy group specified, we can select this this option for the credit, and the tool will calculate that as the number of points. Now notice that some of these are mutually exclusive, that you can't claim multiple credits for different efficiency levels. You would have to claim the credit for the highest level. So if we were to try to do something here and claim a credit for cooling efficiency here of 5% as well, we will get a flag or a check here indicating that there have been too many cooling requirements selected. We'll undo that. Now let's look at the specific calculation and how some of these proportional credits would work. Recall for things like efficiency as well as lighting that you can have credit in excess of even these category levels for further additional credits. So for lighting, we're going to look here. I'll highlight it. There's a lot of text here. I'll highlight it so easily seen. To reduce lighting power by greater than 15%, you can get additional credits. Well, recall that we had specified a lighting level of 0.30 versus 0.45 of the code minimum. So that's a 33% reduction. So what this tool can do is we can update the credit in a simple proportional calculation to show that rather than just get 3 credits at a level of 15% reduction, we can get 7 credits for a 33% reduction. So these credits are available with rounding up to the nearest whole number. Now, as mentioned with the renewables, some credits have limits, upper limits, but some credits you can get additional credit points through reduced levels. I did want to show you, just scrolling down towards the bottom, that we have a credit available for all electric water heating. So this is a fairly big credit. Note that even though this is not an all electric building, that we can get a credit for all electric water heating here. So all of these credits are available, and at the end, the tool will calculate the credits here for each occupancy group and then weight them to verify that the credit requirements were met. So that is the energy credit summary. I did want to show some of the other tabs briefly to show that the building envelope requirements are also documented here. So the applicable maximum U factor requirements, the envelope air leakage, air barrier requirements are required here. And a drawing or specification number should be submitted to streamline compliance. There are also places for HVAC requirements here, as well as service water heating and power and lighting. So let's go back to the credits tab. So we see for this project, we're going to have a complying building because we're going to get credits once we weight this in excess of the 40 credit requirement. Let's jump back. We will have time for Q&A in case there's any questions on this one. But let's jump back to the main training to resume the training. We just have a little bit more to go. Cold climate heat pumps is a new energy credit specific to Denver. These are systems that work especially well at low ambient conditions and provide much better energy performance through reduction in electric resistance heating during cold outside conditions. To achieve this credit, they have to have minimum COP or coefficient of performance of 1.75 or higher at 5 degrees dry bulb ambient condition. PTACs or Pecca thermal heat pumps have to have a COP of 1.5. So this is another credit that's available. There is a listing. This is not required. A system does not need to be on this list to be eligible for this credit, but I put down a listing of heat pump products just so you can see some sample products that may meet this specification. And most of these on the list would meet this minimum specification. HVAC credit cooling efficiency. We saw how this was done with the lighting, so I won't go over this in too much detail, wanting to get through the rest of the material. But if you have a credit for a system that exceeds the cooling efficiency requirement by greater than 10%, you can use a proportional calculation to achieve even additional energy credits. Now note, for a system that has multiple ratings, so say a larger 10-ton rooftop unit that has both a full load EER rating and a part load or IEER or integrated energy efficiency ratio rating, that both of those ratings would have to exceed the minimum thresholds by that given percentage to receive that credit. So this shows the example, or you would calculate the improvement relative to the minimum requirement, efficiency requirement applicable to that equipment class of product. And for this case, the limiting factor is the IEER. The efficiency rating would have just a 17% improvement. So you would be able to claim at least 10% improvement beyond the minimum efficiency levels for that credit point. So once again, the credits would be calculated using the available credits and rounding up to the wholest year number. So since we can round up beyond the 10%, if 10% gives us 4 credits from the credit tables in the code, we would be able to round up and get 7 credits by getting 17% reduction instead of 10% reduction. So this is a way to incentivize very high performance equipment on projects that may be used. So just in summary, when you look at the tables for the C406, if it looks like there are a certain number of credits and there's limited options for achieving that credit total, keep in mind that some of these efficiency-based calculated totals can enable you to achieve credit points beyond what is just listed in the table itself. So it will make it easier to achieve the required number of credit points. Another example here is a grocery store that contains a 10-ton rooftop HVAC systems, each with a constant volume supply fan, a 4,000 CFM, return fans, and heat recovery. This is a new credit for Denver, by the way, the fan power allowance, reduced fan power. If the heat recovery device's effectiveness is 70% and the total brake horsepower, BHP, of all systems together is 23, would this system be available for credit? So the first thing we have to do is determine what the allowed fan power is using the table and the standards, and we would use this A term for the adjustments to adjust for heat recovery. We calculate the base allowance. Again, not to get bogged down with the calculation, but to go through the methodology. We would calculate the base allowance, and we would add any pressure drops available for both the for the heat recovery for each of these 5 units available here, and we would add that to the total fan power allowance for the brake horsepower. If the net result is an allowed system brake horsepower of 26.2, and we have a design of 23, that's a 12.4% reduction. So we can go into the cross section of the table that has that credit, and we can claim 7 credits towards the available credit total for these fan systems. So this is another one. It's certainly design specific, but it's worth checking because the fan power allowances in the code do have, as I mentioned, additional allowances for energy recovery, ducted returns. So it's worth checking to see if your fan system is already exceeding the minimum code requirement. ComCheck will be updated in the fall, as I mentioned. If a new project is submitted for permit before this update is completed, projects will have to comply with all of the prescriptive requirements of the code. So if you're working towards an interim workaround for compliance using ComCheck, please do the best you can to provide supplemental documentation before the update is available. Identify the efficiency credits, apply the efficiency credits that you're using, and add markups to your final ComCheck to add clarification. So this isn't a huge time window, but if your project falls under this time frame, please use this process for complying using ComCheck. Most of the additional efficiency credits will be inspected by comparing installed equipment for permit documents. However, two types of credits, renewable energy and reduced air infiltration, require the reviewer to flag the inspector. The reviewer will enter the credit on the scope of work box on the permit from the list on the slide, and the inspector will look for the required renewable energy and issue a TCO until this is complete. The inspector will also review the air leakage testing report for the air infiltration threshold. So these fields are, again, are Denver specific for further reduced infiltration and renewable credits. Now on to commissioning and envelope verification. These are two things that are required for all projects as well as prescriptive compliance. As we saw in the prescriptive checklist tool, there is a space on the general compliance tab to document compliance with the commissioning requirements of the Denver Energy Code. Now, when is commissioning required? Per C408.2 of the Denver Energy Code, under Section 408, mechanical and service water heating systems must be commissioned when the total equipment capacity is 480,000 BTUs per hour, or 140 kilowatts, or in other words, 40 nominal tons or more of cooling capacity, or the combined service water heating and space heating capacity is 600,000 BTUs or more. Systems serve individual dwelling units and sleeping units are exempt from this requirement, and systems in existing buildings where the area of work is less than 10,000 square feet are also exempt. For the code, under section C408.3, lighting systems must be commissioned when the new installed lighting load is 20 kilowatts or greater and the work area is 10,000 square feet or more. There are plans in the future to possibly update this threshold from 20 kilowatts to 10 kilowatts. Again, this is flagged for a approved update in June that should be pending. Please check with Denver for that update. Existing buildings undergoing a major equipment and replacement of the same capacity thresholds will require commissioning when most of the devices directly connected to that equipment are also being replaced, such as in a complete floor demolition. Commissioning must be done by a licensed professional or an approved agency, which is one responsible for the execution of the commissioning process and must have at least one of the following qualifications: at least 2 years experience commissioning projects of similar scale with a licensed professional engineer designation, or a building commissioning certification from an ISO 17024 accredited agency, or staff credentials recognized by the Building Commissioning Association, such as the certified commissioned professional or equivalent. The commissioning compliance checklist documents the commissioning process. It summarizes the results of the process not only for HVAC, but also for lighting and service water heating. Typically, before functional testing, a test and balance or TAB contractor performs testing and adjustment of the airflows and water flows for all major equipment to ensure that systems operate as intended on the construction drawings. A letter shall be provided with the qualifications of the contractors performing commissioning with the permit documents. An approved agency responsible for the execution of building enclosure commissioning must have one of the following qualifications as well. A building enclosure commissioning certification from the ISO 17024 accredited agency, or staff credentials similar to those previously mentioned, such as building enclosure commissioning authority with building enclosure, a building enclosure commissioning process provider, or a certified building enclosure commissioning provider. Prior to the blower door testing, the air barrier needs to be inspected. This happens at rough-in when the air barrier is accessible and still has the potential for correction. Just keep in mind, if the tests fail, but they don't fail by more than 150% of the requirement, or 50% over the requirement, that there's a opportunity to provide corrections through sealing and identification of leaks without retesting. Envelope verification requirements of the 2022 Energy Code are very similar to 2021 IECC, except that Denver has removed a few exceptions for requirements of testing, such that all commercial buildings will require testing. New envelope assemblies of an alteration do require testing. Repairs and roof recovery and roof replacement are exempt. Dwelling units and sleeping units, for those, sampling is allowed for 8 units or more, but you have to include the top floor unit, the ground floor unit, as well as the largest unit. And at project completion, a report with testing results identifying any corrective action is required. Air leakage rates, these were mentioned briefly before, but this mandatory provision requires continuous air barriers and verification at installation. The air leakage testing has been modified to now require the air leakage to be at or below the CFM per square foot target. So the target for sleeping dwelling units is 0.3 CFM per square foot, and the dwelling units are tested at a test pressure of 50 pascals versus the other, non-residential spaces are tested at a slightly higher pressure of 75 pascals, and the target level is 0.4 CFM per square foot at the higher test pressure for commercial buildings. So if the tested level is above the maximum limit of 0.45 for dwelling units or 0.6 for all other, then retesting is required. If it's between the target and the maximum limit, you can provide remedial measures and identification of air leakage without retesting. As I mentioned before, this training covers the prescriptive compliance path. There will be a separate training that covers the performance path in detail. This is just kind of some very high-level guidance on when you might choose the performance path. With the prescriptive path, it's straightforward to comply, but it's somewhat restrictive in that each and every requirement in the code, where applicable, must be met. Some design-specific criteria may push projects to the performance approach. Common ones might be a building window area that exceeds the allowed levels, window performance, or particularly with curtain wall construction. Moreover, projects with complex HVAC systems may wish to use the performance path. The performance path allows the designer to trade off the performance of one component, such as interior lighting power, with another envelope or HVAC measure. Projects that are already pursuing incentives through LEED, green building programs, or electrification may wish to use the performance approach to demonstrate performance above code requirements. In summary, projects may follow one of 4 pathways to comply with the Denver Energy Code for 2022. The prescriptive was highlighted here. The other 3, the energy cost, site energy, and performance target approaches, are part of a performance compliance approach. This presentation covered the prescriptive path, and keep in mind that the requirements under C407, which include and C408 for commissioning that apply to all buildings, would have to be documented as well on the prescriptive checklist. Successful submittals would include checklists in the drawings, compliance documentation, and documents that show and point to how requirements are met in the project building. Updates to the Energy Code are designed to support and incentivize electrification. There are 2 new provisions for partial electrification, as well as demand response for water heating. And also keep tuned for the minor updates that are happening in June to clarify some of the changes to the code. So for those that are still with me, I want to thank you very much for your time and attention. And I also want to make sure we have time allotted at the now for question and answer. You can use the question and answer feature within the tool to submit your questions. And keep in mind that responses to any questions that aren't directly addressed today will be sent out by email to everyone that's registered. For additional questions, you can use the email cited on the slide for correspondence. And thank you for your time. And I would like to turn this over to our panelists to help address any questions that may have arisen.
Awesome. Thank you, John. Yeah, and like John mentioned, we're here and we're going to use the remainder of our time today to answer any questions you have. So we're going to answer this first one live, and Chuck, I'm going to direct this at you. Casey wants to know, for a packaged air-to-air heat pump system, is a fossil fuel furnace still permitted as backup when the heat pump can no longer meet the space load?
Thanks. So C403.2.4 will not allow the gas backup for the heat pump. You are allowed to use the electric resistance as a backup. The exception to that is if you are replacing a fossil fuel furnace, you're allowed to install a heat pump with a gas backup. So if you're replacing an existing gas-fired piece of equipment, then yes, you are. But if it's a new system in a building, not replacing an existing gas-fired piece of equipment, then no, you are not able to.
And I have another.
Tom, can I add one point to that?
Sure, go for it.
Chuck's certainly correct. So, with the colder climate in Denver, one option, it's not required for all projects, but if you use a DOAS system to handle the ventilation load, then that will ease the heating load on systems such that you can have energy recovery to handle that ventilation load and have some of your heat pumps just handle the space heating and cooling directly. Is one option.
And I'm going to direct this next question to Linda. Linda, does the checklist take the place of CommCheck?
Good question. So we've referred to the checklist, but that is probably best to think about the checklist as an index to drawings and your permit package so that the reviewer and inspector can find all of the provisions. And ComCheck or compliance documentation is separate. So while we're in the interim period before there's a Denver specific ComCheck, the combination of ComCheck for IECC 2021 and maybe supplemental documentation will be used for that compliance documentation.
Thank you, Linda. And I might ask another one of you. So does C406 apply to exterior lighting?
There are a few provisions in C406 where a project can get credit for additional lighting efficiency. Those are for interior lighting, not exterior lighting.
Okay, awesome. Thank you everyone for participating. That is our event. We'll be back same time next week. So if you enjoyed this, tell your friends, come see us again. And thanks for your participation and attendance.